Hi viewers, I welcome you once again to my YouTube channel. So far we have seen these three broad categorization, like it is a distributed database and it is decentralized record of transactions. It is storing information electronically in a digital format, and this is the fourth point that we have seen, like it is containing information together in groups, right? So now we are with our fifth point, right? I mean the fifth point of blockchain, which is I consider is very important, like it's tamper proof feature, right? It's immutable. It means like the block once added to the blockchain network, you cannot go and tamper with this block or the transactions that once made in it. Like let's say this is a person A, let's say this is the transaction T1 is saying person A has sent person B, let's say 2 BTC, 2 Bitcoin he has sent, person A has sent person B 2 BTC, right? And this transaction is included in the long-term consensus chain. We will see this particular term later, but let's say this is the part of the blockchain and this is the part of the valid block. This is a part of a valid block, and if someone is going to come back and tamper any this transaction, let's say this he is going to tamper this T1 transactions, how he will do that? He will say no, he hasn't sent money to B, rather he has sent money to, let's say, K, and he adversary is K, like he want to take steal money from B to K. So he's saying like money that A has sent to B doesn't belong to B, rather it belongs to K. So if he cannot do that, this particular feature is not possible, or this case will be directly rejected by this particular blockchain. So this is the very important feature. But before going into detail of that particular aspect, I want you to quickly walk you through the hashing feature, right? So yeah, I want you to see one particular illustration, and then we will go to the online hash calculator, and then I will show you beautiful hashing algorithm. Hey, see this very funny meme that I find for you. Okay, so here it is saying like अंदर तो आ गए बाहर कैसे जाओगे. So hashing is like it's one-way process. Suppose you are giving it some particular input, so based on that input it is going to generate some hash, right? It's just like a function. Let's say if it is fx, right? X is the input and fx the output of fx. I mean fx is the output, and if fx is going to generate some sorts of output, so that output is basically hash, right? I don't need to say like fx and x, it might confuse you, but let me go through the presentation. I'll give you a very quick understanding, right, what I'm saying. So what I meant to say is, suppose your input is x, right? So input x is, let's say, 1 2 3 4 b c d e f k p q, whatever, right? Whatever is the input. If you'll put, let's say, in f of x, this is hash function, right? It is going to generate some sorts of output, right? That output is fixed in length, fixed length output, right? That output is fixed in length. If it is SHA 256 algorithm, the output will be 256 bits long, right? 256 bits long, or 32 byte, because we know like in 8 bits we have 1 byte, right? So due to that we have 32 bytes in 256 bits, right? So why I'm saying SHA 256 only, because this SHA 256 is going to be used by blockchain, and Bitcoin is using this only, so we'll be also seeing this only, right? So what I was showing you before a few minutes, I was showing you one meme. In that meme it was saying like अंदर तो आगे बाहर कैसे जाओगे. It means once you know the input, that's fine, you are going to find the output. You will say like, hey, this is the output. But once you find the output, right, let's say you are finding the output is something like 00k, let's say 00a 1 2 3 4, right, and 009, something like that. Let's say it's 256 bits, or it is 32 byte, right? So what is happening, if I'm going to give you any particular hash, like let's say b a 01002, something like that. Suppose if I'm giving you such type of such type of output, and I will say, hey, can you find for me like what is its input? So you cannot do that, because it's one way process. You cannot recover the input from the output, but once you are applying hash function to any input, you will be getting some sorts of output, right? What I meant is, I'll quickly go through the online hash calculator, and I'll show you what I was saying. So we are here, like, let's say I have written for you there is like Valentine week sucks. I'm just trying to find this is such as a 256. You can take any of the algorithms like MD2, MD5, MD4. I'm just taking it like SHA 256, right? SHA 256, secured hashing algorithm. SHA is for secured hashing algorithm. It's full form. Okay, you just hash it. After hashing, come on, man. Okay, so here we have our result is present over here, like 3B 55 3C F39, something like that, right? So if you're writing Valentine wake sucks, we have this, right? In SH 256. Okay, you just remove one S from here, and you'll see just a slight modification has change the entire result, A88, something like that, right? So this is the input, right? And this is the output. You're saying the output is of fixed length, right? I'm just doing anything. I'm copying it like it to make it just big, just to make the input big. Let's say I'm copying it over here, right? I'm further pasting it. I'm just showing like even if the input is bigger, the output is not going to change its size, right? It is still 256 bit. Since it is in hexadecimal, you're not able to say like, hey, this is 256 bit long, but it is 256 bit, right? You will convert it into the binary, then you will find like, hey, yes, this is 256 bit long, right? So this is something that I wanted you to know. And let's go back to our presentation, and I will I'll summarize 2 or 3 property about this hashing, and then we'll go for learning how exactly this blockchain is providing the tamper-proof property, right? Okay, so if I'll say, I'm just summarizing it quickly, I'm not going into that much detail, but if I have to summarize it, I will say number one is, it is a one-way process. It is a one-way process. I'm sorry for my handwriting, it's not that good. Number two is, input can be anything. Its size can be of any length, right? Any length. But output will be fixed in length, that is 256 bits or 32 bytes, right? This is the second property. And third property is, let me tell you a third property. Same input will result in same output. I mean, suppose if you are giving 1 2 3 and 4, right? If it is going to give its hash as, let's say for example, X Y Z P Q. I'm just, it's not SH256. I'm just saying there is any algorithm that is giving you X Y Z P Q. So if you will again type 1 2 3 4, it will give this hash only, right? One of the very famous example of hashing is, let's say you are going to Facebook page and you are typing your password. Let's say your password is what? Let's say your password is Kumar 243, right? Anything like Kumar at the rate 243. So if it is going to generate its hash as, let's say PQRST, anything like that, right? So this Kumar 2 at the rate 243 is not going to be recorded by the Facebook in its server, because if adversary or if anyone attacker wanted to go to database and he is trying to see what exactly my password is, he will find its hash, right? And if he will find its hash, as I have said, you cannot go back to the output. You cannot go back to the input, what input was. Once you know what exactly is the output, you cannot go back to the input. Suppose what I meant to say is, let me clear it. What I was saying is, suppose if you are giving it as let's say 2, I have sent 1, 2, 3, and 4. It is generating P, Q, R, S, T, V. Suppose, for example, it is the output. This is the hash output, right? But if anyone says, if the hash output is Q, P, V, Z, K, then guess what will be the input. You cannot guess, right? You cannot guess what exactly will be the input. That's what I was saying. When you will enter your password, like Kumar at the rate 243, this is what I said, right? For example, so Facebook database will not record this. Facebook will take hash of this, and whatever Facebook will record will be its hashed form, so that if attacker is going to attack its database, in case, though it is very secure, but if it is going to attack its database, it will only find its hash version, and through hash version he will not going to recover what exactly my password was, right? What exactly my password was. So this is something that I wanted you to know. And in the next lecture, maybe we will see how this tampering works, right? How anyone cannot tamper this any block, in fact, in the blockchain, right? So yeah, see you in the next lecture. Bye.